So hey, hello everyone. My name is Ramon. I work at Google, like the logo says. I'm a senior staff, site reliability engineer, SRE for short, because that's very long. And I'm going to be today speaking about production outages and how to make them shorter, not how to make them disappear, because they are going to be happening all the time, right? So I was thinking to show my achievements at Google, right? And I thought it was a bit over the top, but I'm going to do it either way. So if you know this page, right? Have you been familiar with that? That's what my team does. I'm the technical lead for the authentication services in the SRE side. So we run everything that goes from this small front end that has just a single text field, but a shitload of JavaScript that is doing, for example, like hijacking protection, right? And is detecting bots and preventing spam and all that stuff, and has like a load of backends in there. So we have things from like an older monolith that we are migrating to microservices. We have like tons of different storage services from one custom-made database to a spanner that you might know that Google is using like frequently. So all these things is doing hundreds of millions of QPS in the backend and uses 190 services under the hood and several petabytes of storage, right? Just for authenticating. The whole company depends on our services. So whenever we have an outage, it's like, oh boy, right? So things like workspace is down, things like search ads might be down, right? So we're going to only show like search results and crappy ads, right? So all the company revenue and services and stuff from GCP and company gets affected. So every time we have an outage is let's just say stressful kind of thing, but we manage to do it. One thing that we do, though, is in SRE, we contribute to the design of the services so they are very scalable and they are resilient and they are planned for growth of, like, let's say, 10x of where they are now. And we do have a very nice reliability record. Not in vain, many people, when the internet connection goes down, they do ping google.com to check that the things are working, right? However, sometimes shit hits the fan and stuff breaks, right? So I'm going to show you my best achievements in this respect. This is from 2015, right? In December, one of our storage backends during a schema change broke, and we have an outage that was all over the news, right? This one is something that happened in 2017, and we were doing another change in our storage, and we were signing out casually hundreds of millions of users, right? So that's the impact that you had when you are running this class of services. The last one, this is the one that I'm most proud, is so we did in 2020. Put some automation around. You can read about all these outages in our status page because there is like some sort of a small postmortem for you to find. But I think it was fine to have these images. So there is a nice outage in the sense that we were having automation for quota management in some storage, and the quota decided that there was too much, and 0 would have been more suitable. So one of the storage services, there was the cornerstone for authentication, was not working. So that's what happened when your stuff breaks, right? And what we know is that happy users will stay, happy customers will stay with your services, but unhappy users will leave. And it's not only about latency, and it's not only about the quality of service, but this as well about the perception that your customers and your users are going to have of your product if you keep having outages one after the other. More especially in, for example, enterprise products or the cloud, where like the cloud platform, where companies will depend on their business will depend on your platform, right? So let's just go through a nice graph here. So this is the user happiness over time, right? So we have a user in there that has 4 stages. At the beginning, user is happy, is in the blue zone, which means that things are working well. But then something happens because the happiness of the user is going down and up, and then it just tanks forever, right? So one thing that happens is an outage begins, right? When an outage begins is when something breaks in your system. Doesn't mean that has to be materialized in the sense that the customers or the users will see it. You might submit your commit for a schema change, right? And that's the beginning of an outage. It's just not failing RPCs just yet, right? But that's where the root cause or where the starting point of the problem happened, right? At some point, things will become visible to the users, or things will become visible internally to you, in the sense that, for example, you are going to start seeing like your expenditure in cloud goes bananas because you are like retrying all your RPCs and so on and so forth, right? But there is some point where the problem becomes visible for your customers, for partners. There's someone that notices, right? Ideally, right, there's going to be an alert, right, that is going to tell you that something is going on in your service, right? Ideally, this alert should happen before this thing is visible to any of your customers, any of your partners, any of your users, right? It doesn't have to be that all the way, right? You might have alerts that they trigger later in the outage lifecycle, right? So this is what we call the time to detect, right? So this is the time that passes between an outage begins and you notice that something is going on. That you don't need to know what is going on, actually. You know that something is broken. It could be something short. For example, if you have a service that has a lot of volume, right, and something breaks, or it's a service that is critical for a core service for the company. For example, the time to detect usually is short. But it could be as well months between a change that's happening in your system and something that you are detecting. For example, I'm sure everyone that is running services here will have RPCs or endpoints or APIs that they have like a lower volume. So you might have in your 100 million QPS an endpoint that is only doing 0.1, right? If that's breaking, for example, you are going to probably take more time to detect that is happening, right? What happens next? You get the page, you get the notification, you get the escalation, whatever it is how you detected the outage, right? And you start working, your on-call rotation gets into an incident room, you just start scrambling, you're going to take a few hours to fix it, few days, few minutes, whatever it is, depending on the outage that you're having, right? And the issue is finally mitigated. Doesn't have to be resolved in the sense of like completely repaired, but it might just be mitigated, right? Meaning that the users, they may have seen service again, right? And then the happiness of the users goes back, right? As you see, it doesn't recover to the same point it was, right? Once you have an outage, that stays in the media, stays in the users that they saw the outage, stays in the business that they saw it, right? So the confidence the customers are going to have in you is going to tank very quickly and it's going to recover slowly, right? This is why doing things like, for example, publishing a post-mortem, telling them what you are doing to fix your service, to change it so it's more resilient, is important for them to build confidence again. So this is the time to mitigate. We can approximate time to mitigate and time to repair by mostly the same, right? And at that point in time, service is recovered, and then the trust on your users in yourself is in your service is going up, right? But then you have another outage. And you know you're going to have another outage, because after one outage, it always comes a second one, right? There is going to be always outages all the time. Everything is breaking all the time. I know that my services, they're running in broken machines. Disks are being repaired in data centers right now. Like network links over the oceans are being broken. So I know everything is broken, right? And I know that I'm going to have an outage. How big, how small, yeah, we don't know. The thing is that the next outage begins. Right? And there is a fact of life that there is a time between failures, right? So between one failure and the other, things are going to happen. It looks, for example, that this second outage was really bad and the user was really unhappy after the fact. So we're going to be drilling down on these three concepts in here, because that's how you make your services more resilient. You will never have services that they are invincible. You will never have 100% of availability, and you should not target 100% of availability for one simple reason. A, it's technically impossible, right? And second, is just too expensive, right? For every time that you add 1.9 to your availability, for example, going to 99% of target availability to 99.9, means multiplying by 10 the complexity of your services, because you are going to divide by 10 the time of an availability or your error budget that you are going to have, right? So if you add 1.9, right, you are increasing the cost of your service by a lot. So going from 99 to 100 means that you have to do that addition of nines infinitely, right? So there are services that they do have to have a very high availability. For example, we have services that they have 6.5 nines, right, internally for things like cookie validation, etc., right? And it makes sense because a lot of the business, for example, depends on that. Many other services that we do have, they don't have more than 2 or 3 nines, right? And that's fine. That's OK. So when you have these outages, one of the things that you have to do, and I strongly recommend to do it, even if you have an outage that didn't make it to the news, right, is to have postmortem. A postmortem is an analysis after the fact of what happened, right? So the primary goals of a postmortem are basically documenting what happened, right, explaining what are the root causes, right, and explaining what are the root causes of one of the outages is hard because you might be tempted to say, like, well, there was a submission of this, this commit, and this was the problem. And that might not have been the case. That might have been the trigger of a deeper problem that was in your system. For example, a design choice that was made years ago, and platform choice, whatever was it, right? So the analysis of what happened needs to be really going deep. We use a method that is called the 5 whys. So you keep asking why 5 times, right? Until in the 4th, for example, you say, like, I don't know. If you don't know, means that you have not yet found the root cause. So there has to be as well an analysis of the interaction of the different components and systems. We have one concept that is called the complex system interaction, right? Which means that you have a system that is super complex, like the authentication stack, and another system that is super complex, that is the Gmail stack, and they react badly in very specific conditions. This needs to be understood, right? And a postmortem is completely useless if you don't have action items after the fact. So it's going to be a nice descriptive exercise of saying, like, so this is what happens, and this is why it's broken. Thank you, bye. OK, you just wasted a lot of time, right? So you need to have actions to correct the root cause so your class of problem doesn't recur again, right? So ideally, postmortems should only repeat once, right? You know you're going to have another outage later down the road, but it should be different than the one that you had, right? Postmortems as well, think that the audience of a postmortem would be your C class or your C-suite kind of thing. So you have to have like an executive summary for other teams, other people, your executives to know what is going on, what happened, as, for example, a prioritization exercise. When you decide what projects you are going to be doing next year, you might want to take the postmortems into account to understand what are the projects that you could put in your platform to make it better, right? There is another concept that is very important in the postmortems that I always try to hammer down in every single talk that I do about postmortems. That is blameless, right? So it's never the case, I can claim that it's never 100% the case that some person is the root cause of a postmortem. It's never that someone submitted a comment. It's never that someone was on holidays while the outages happened. It's never that someone did not look at processed food, right? The fault, in generally, is either design choices that what happened for the system when it was developed, right, or processes faults, right? So what you need to fix is the systems around your product, not the people, right? If the system that you have cannot sustain, for example, like a lot of spiky traffic, so you go from 100 QPS, for example, to 1,000 in one go, right? The problem is not your customer. The problem is that you don't have rate limiting, right? For example, if you can't have, I don't know, certain class of commits that they go and they screw your JVMs because, for example, they increase the GC collection time or whatever it is, right? The process is not that someone used that feature. The problem is that you didn't have a code review process to prevent that to happen, right? I think this is very good. This is very good to do, right? And as well creates a culture that is reinforcing, right? Because then people will be comfortable and will have the safety to actually write the postmortems in a way that actually goes down to the system problems and the actual root cause of what happened. So what do we do with these three, going back to this? So we do the postmortem side, and we go back to these 3 times. Right? So how we make this outage and these times shorter, basically. Well, shorter, and the time between failure as longer as possible, as we can. Right? So in the time to detect, what we need is to have better observability. We just had an observability talk, but in the sense that it needs to detect anomalies of things that they are happening in our systems, right? So we need to define metrics that describe our product, right? And metrics that describe our products, I think, is a very interesting concept because you don't want to know how many disks are failing. I don't care, right? Your customer is not going to care. Do you care how many disks are failing right now that they're storing the data of your Gmail account? No, you don't. You care about your Gmail account on your email to be available, right? That's a metric that is interesting to collect and to analyze and to study. This is what is called service level indicators, right? So you are going to have service level indicators from the perspective of your customer. Latency, for example, of like how fast the pages are being shown in the browser, how much data durability you have, how much is the time to, for example, in the calendar to like set up an event in storage for having a fast response, et cetera, right? Availability, of course, as well, right? Then you're going to set SLOs, which is objectives for these metrics, right? For example, an SLI for latency could be, this is the proportion of pages that load under 200 milliseconds, right? That's meaningless by itself, right? It's good. It's like, could be 50, could be 99.9, just an indicator, right? You need to define objectives for that metric, right? And then when you say, like, I want the number of pages that they load on 200 milliseconds, right, to be always over 99%. That is meaningful, right? Because then you know if you are doing well or not, right? If you are in over 99%, you say, like, the system is performing as I wanted, right? Or if you are under that threshold, you know that there is something going on and you are not meeting the expectation of the users, right? And of course, once you have this, right, you can set alerts over these SLOs. You can say, like, okay, if this SLI goes under the threshold, I know that I'm not meeting my expectations. Therefore, kindly please send me an alert because I want to fix it, right? The time to mitigate is the time to repair. So one of the things that do help is training your people, right? Not only the responders, but as well developers. You want to train as program managers, product managers, for example. So when they see an alert flying through your chats, right, they know what the alert is meaning. Right? They might not be the ones that they are going to go and respond to the alert, but they know what's happening with the product. Right? Playbooks and runbooks, they are very interesting as well because they are going to, when you receive an alert, you click in a playbook and you say, like, well, this alert, you know what this alert is for? So this is telling you that some of the whatever interaction with other service is broken, right? And then in 5 minutes, you know where you are, like what is the scope of the problem that you are handling, right? Responder fatigue is something that is as well interesting to look at. That is, how many of you have been on call in the night? Right? If you can, don't, right? Because you don't want to be paged at 4 a.m. because the first thing that is going to happen is that you have to wake up and you're going to take 15 minutes for that. And the second day you have a page in the night, you're going to say, like, screw it, I'm not being on call anymore. Or if you have a shift, right, that is going to have 16 pages, that's a page an hour. You don't have the time to like look at all that. So you need to schedule your shift. You need to have more people in the rotation. You need to have more than one rotation because you have more load. Or more interestingly, you need to prioritize projects that make your system more stable or your alerts less noisy or your system faster. So you don't have this many amount of outages or incidents, right? And finally, you have the time between failures. The time between failures is with the interesting part of stuff, at least for me, right? That is, you're going to need to change your system so it's more resilient. So have a design that actually sustains the demands that customers have and the growth that your customers are subjecting it, right? So there is nothing to detect because the system is self-healing, for example. So if you have a distributed system, right, and machines are being like breaking, and someone is changing one machine to the other, you want to have, for example, a distributed storage system that will just self-heal for that, and you don't have to do anything. It just will just, for example, create another copy of the data, resilver a ZFS pool, whatever it is, automatically, so that's it. So in the majority of the cases, the system just responds automatically. There is a lot of best practices and CI/CD that you can put together. For example, whenever you send an RPC, have a library that will do the exponential backup for you and will be able to establish some policies in there. That's it. You just put it in there, you put it in your framework or whatever, like some best practices you have, and everyone just uses it automatically, right? CI/CD. You integrate your stuff, you deliver it, run some tests. Why not? Tests are good, right? Test in production, by the way. That's the great way to test. I'm not kidding. Just test in production or leave the lie, right? You might have a test environment for doing unit tests, see things integrate and so on, and then just go to prod. Go to prod, because it's good, right? Go slowly. Right? You don't want to say, like, I'm going to test in prod in all my users all the time. It's like, well, I mean, for sure you're going to detect problems. That's clear. But you can deploy, like, 1% of the users are going to receive the new version. And you know that that's actually real behavior and a real environment. And then you do, like, 1, 2, then 10, 15, whatever. Right? And then chaos engineering, this one is nice. Break your system on purpose. Right? Wow. So there is a nice, I think chaos engineering was introduced with that name by Netflix. There is a book that is called The Chaos Monkey. And it's an interesting concept because it's like the only way to succeed at failure is failing all the time, right? So have something that is breaking your system all the time. So you have a Kubernetes cluster. Get some cron job that is killing some nodes all the time for having the system moving pods around. So you know that there are some systems that, for example, do not have sufficient pod replication, or you know that you need to have in your storage to have more replication of your fragments or your stripes or whatever it is, right? So when something breaks for real because a machine gets corrupted or whatever, you have already exercised that path, and you know that that works well. Good. Let's just zoom in. I don't know what that picture is. Someplace. So how do we shrink the time to detect, right? So ideally, there is one condition that is ideal for the time to detect, or two if you want to, that is alerts should be meaningful in the sense of, like, if you're a page, it better be because something's actually broken, not of noise. It's like, oh, there was a blip in traffic and I was page. OK, right? And second, ideally, you should be page before the customer sees the thing breaking. So by the time the customer sees breaking, you already are on the job, right? So the SLIs, I have seen many people moving to use SLOs and SLIs, right? And using one thing that we call that is cost-based alerting, right? Or going to cost-based SLIs. And it's having an SLI over something that is not your core know-how for the service, right? If you are within a company and you are providing the infrastructure for storage, you might want to have an SLI for data durability, for disk availability, etc. If you are providing the functionality for your card there, and then you have a card with your things, and then you pay with the payments processor, and then you just ship it, right? You don't need to provide an SLI for the availability for the disks, because that's not your core know-how or your core competency for the service that you are providing, right? So you need to measure as close as your customer as possible. If you can instrument the client, the better, because then you are going to have exact visibility of what the customer is seeing, right? In the sense of, like, for example, if you have a mobile app, right, you want to instrument the mobile app so you see the latency in your customers, not in your API endpoint, right? Because then you can see what is the latency your customers are having over the network, what is the impact of, like, being in one country or another, right, which is completely different, right? Ideally, you might have external sources that are not monitored by yourself that will confirm that. So you might have probers in other infrastructure, for example. You might have, I don't know, things that they are simulating users in another cloud provider, so you could see how you are responding, right? The SLOs, they're a very interesting question. So how do you decide if you want 5 nines or 1? So how do you decide between 99.999% availability or just 90, right? If you go to a PM, to a product manager, they're going to tell you 5. Because it's very important what they are doing, right, for the company. And what do you do, right? Developers, they're going to tell you, like, no, I want 90 because in that way there is, there is less the service needs to tolerate can tolerate more risk, right? And I can ship features faster, right? If you go to an SRE, they're going to tell you there is no need for an SLO because the system is never going to change. We're never pushing it again, right? Why? 80%, 70% of the outages happen when you change the system. So if you want high availability, do not change it, right? Doesn't end well, that strategy, but I mean, it's one strategy, right? So what you have to do is put them in the same room, right? You put your product managers, you put your developers, you put your SRE or your DevOps people, and you say, like, so how we're going to converge on that? By the cost. Right? When SRE sells like, sure, we can have 5 nines. That's perfectly fantastic, right? We're going instead of using MySQL, we are going to need to write our own storage service. We are going to need to have at least 5-way replication in 2 continents, and we are going to need to use 2 cloud providers, right? the PM will change, right? The phase will change, and they're going to say, wow, that bill is going to be hefty for doing that, right? So they're going to say, what if we settle in 2.5, right? And then it's going to be an agreement of yes, that's what we need, because that's what we can afford or what makes sense in cost for the importance of these projects for the company or for your business, right? And then you are going to have something that is sensible in that sense, right? And then just create effective alerts. One note about the operational cost, right? I think that many people says I'm not going to do operations. That's not for me. I don't do tickets, for example, right? I only going to do projects for automating them, and so I never have a page or a ticket. That's great, right? You're going to have them. There is value in doing operations, right? Because there are some things that happen in your system that you just resolve. You sit in there, you resolve your ticket, that's okay. It's going to be more expensive to automate it than to do it once every 2 years, right? So balance that out as well. Good. So how do we rank the time to repair? This is a completely different beast, right? Because the time to repair is triggered, or you are going to materialize it when something is already breaking, right? So you need to put yourself in when you are trying to shrink the time to repair, that when you are going to be operating your system in this moment is because the system is broken, right? So the first thing that you have to do is understanding that the responders, they are actually properly trained. And properly trained not for develop the system, but for doing two things. First of all, introspecting the system, right? We saw the prior talk about the OpenTelemetry. That's great, right? We have a thing that is similar. So when you have an incident, one thing that you want to say is give me a sample of something that is broken, right? So you give your Dapper trace, and you immediately see oh, these are all the RPCs that they are going on. This is very slow, right? So you need to train people to think about the system in this fashion, right? Not by navigating the code, which, yes, you are going to have to do it as well, potentially, for doing the response, right? But it's a completely different activity, right? We call it disaster recovery. We're doing one these days, right? And it's like a theoretical failure drill. It's don't wait for failures to happen. Train it before they happen, right? So we are training a scenario of what happens if one of the, let's say 5 clusters or 5 data centers go down at the same time? How the system could respond, right? So you can even take them down yourself, right? If you know that there is some tolerance to some failures, that you can trigger them, right? And see how the system responds, right? Then the runbooks. The runbooks are very interesting because when you get the alert, right, the first thing that you have to do is acknowledge that the first 5 to 10 minutes, you are going to go by gut. You are going to go by your perception of what is going on until you more or less narrow down the problem, right? So if you get a page that your SLO is not being met in a system that has a 90 microservices, whatever it is, right, of complexity, the first thing that you're going to do is say well, I have seen this in the past. How would I go, right? This is very interesting knowledge to provide to the responders when they get the page at the beginning, right? So if you responded to an issue, right, just take notes of how it went. What things did you look at? What was suggestions that other people could have, right? Just write it in there, because the next time you're gonna see one of these outages, right, that's going to be very useful to have. Right? The responder fatigue. So you don't respond the same when you are responding to the 5th page in the day than to the first one, right? We train and we schedule the rotations and we staff them, so you are going to have no more than 2 incidents per shift. A shift is 12 hours, right? So if you have more than 2 pages per shift, it means that the service, either the rotation is understaffed or the service is too unstable. If we enter these 2 incidents per shift, means that we have too much toil to project ratio, and what we are going to have to do is schedule high priority projects to actually take the service back to a place which is operable, right? When you can operate the service in a way, right, that is reasonable for the people running it, right? Shed load, that's interesting as well, and is when someone is responding, I have seen many teams at Google, right, and in other companies, that the responder that gets the page, they're going to say, I have to fix all of it. It's no, there's more people. Just look around or go to your chat if you're remote or whatever. There's more people. You can ask for help and ask, can you look at this while I look at the other stuff? That's okay, right? So have that culture, right? And then there is the dashboard and logging, right? So In the first outage that I showed at the beginning, the one that was in 2015, right? I remember distinctly that we spent a few hours trying to navigate our logs, right? We were trying to filter them, then to like sample and then to like cross them with other log sources and so on. For one reason, it's like the outage was affecting a very small fraction of our traffic, right? And it was just, if you see a dashboard with just time series, you just wouldn't see it, right? In time series, you needed to know what you were looking for. So have your dashboards, your logging, your tracing, or whatever, that is what you use. Ideally, it's the 3 of them, right? In a way that you can actually filter very quickly. Ideally, have something that will tell you anomalies that they are happening, right? If you have time series that they are in different order of magnitude, for example, something that is as simple like putting your graphs in logarithmic scale goes a very long way. Takes you 15 seconds when you configure the dashboard, right? These kind of things make a lot of difference when you are responding to an issue. Fine. OK, now, how we make time between failures, not infinite, but very long. Let's just say you don't want to have big outages more every other year, right? Let's target for that. I think that's a reasonable target, right? So, first of all, there is development practices, right? This is DevOps. The first half is development practices, right? So code quality goes a long way. Having code reviews, having unit tests that they cover like the majority of the cases is a good practice, right? Having as well frameworks of libraries or a set of best practices that developers could just take and automatically apply to their code, right? So if you want to apply some policies for every time you launch an RPC, right, you might want to give developers a look. This is a wrapper that you can just use, right? And it's going to set up the RPC for the best way that we know, right? Exponential backoff, right? Logging appropriately, tagging your RPC for the telemetry to have sense, et cetera, right? You don't want to repeat that every time that you write a service, right? Automated testing is great, right? But automatic rollbacks are better, right? So you can test the service at some point, right? You can do unit tests. They go a long way to like verify that the system works well. I remember as well that the change in quality for the code, some services that were written in Python, just by having a test that was just the Python interpreter interpreting the code, just parsing the code, right? That made a reduction in outages then in production. For a reason, it's like you know that the code has the minimal quality that a Python interpreter will just take it, right? So that's good. These small things go a very long way, and they have no cost. Right? So automated testing is great. So if you have a test environment, you can launch your services, like see if they integrate well, if they are not incompatibilities through the APIs and so on. And then, as I was saying before, go to prod. Just go to prod, right? And have a system for automatic rollbacks. How it works. You roll out like your new binary to 1% of your fleet of binaries, right? One cluster, whatever you have, like a small percentage. And then you have a system that is monitoring the metrics of this 1% against the metrics of the 99. It's what is called an A/B testing, right? If you see that there is sufficiently statistically significant variance in some of the metrics of interest, like your SLIs, for example, the cost of, in CPU, for example, of the binary, latency, you can just have a system that takes that back to the prior version. Sends a message to the operator. It's like, we did roll this back because this metric, it was out of the control to the rest of the binaries. That's it, right? Bullet 3 is the one that is harder because it means designing your system well, right? And this is like saying a lot in just a phrase, right? So design things with not a single point of failure. Aim for that. Like there are going to be single point of failures at the end of the day, right? But have a knowledge of like what are your failure domains, how you are treating them, how you are failing over one failure domain to another, right? If there is going to be a reasonable single point of failure because of cost or because of all the restriction, document it well. Have alerts so you can have like a very fast turnaround with the spot like fails, right? Redundancy is the mother of all reliability these days, right? But graceful degradation is as well very interesting. For example, so Imagine Google search, right? You have a lot of features in there. You have search results, you have ads, you have like the boxes with more information that go to the right? If one of the services is broken, you don't need to fail a search query, right? You can serve the search query and just say like, look, we could only get the results with reduced quality, right? And the other thing is okay. The user will just see it and it's fine. They might research or whatever. If the ads backend is broken, just show search that they don't have any ad, for example. Or if the knowledge like bullets at the right, they are not available, just show what you can, right? It's going to be degraded. It's not going to be the full experience that you want to show to your users, but that's better than showing nothing or a 500, right? And finally, to find issues, right, break your stuff. Break it yourself before the actual thing happens. Good. So this is all guided by postmortems. Whenever something breaks, right, think about action items after you have declared like what is the root cause that will lead to like shrinking these times or making the time between failures longer, right? And you have a lot of opportunities from alerting metrics, from just doing trainings, from reshaping your on-call rotations, to redesigning some part of your service. If you're interested in SRE and why and how SRE is different or equal to DevOps, right? I'm going to be here. You can ask me. This is my opinion. Or you can read these books, right? I wrote part of the first. And then they are interesting. The first one is like more or less the theory. Second is how you apply it in an existing organization. The third one, if you are into security, right, that's one interesting because it's the overlap of security and reliability. Obviously, without security, reliability doesn't matter. You can have a system that is very reliable, but it's serving shit. So, and then there is the last one is one that is focused to like bigger corps and enterprise and how you can deploy SRE in there. Finish. Questions.
And you said you only had 25 minutes or so of presentation.
Yeah.
Again, you answered a lot of them, but there are some that have some +1, so let's elaborate a bit on those. A lot of people are asking, like, OK, you mentioned that there's code quality, testing, all that, but is there any specific training you do for developers, aside from the entry level of an engineer at Google is hired? Any specific training so that developers are aware of that and mitigate outages from the very beginning?
Yes. So I always say that someone that joins Google is a nuclear until they break production, right? And that can be the first day or the first year, right? So there is two ways that we do. First, developers don't have to be SREs. They participate in the response. And we have trainings. We call it incident management at Google.
That's probably the best one to participate.
Yes. And then whenever there's an incident, they will come over and take part. Yeah.
And they were also asking, like, any advice to make the runbooks when there's an outage, there's probably a runbook to fix it. Aside from, I guess, using the search engine from Google to make them easily discoverable, and anything you can share in terms of like helping people write the runbooks and make them discoverable in their wikis and things like that.
Yes. So whenever someone writes an alert, right, they are going to send a commit to me, for example, because I'm in the TL, or to someone in the team, right? And that alert is going to contain three things. The condition, so this alert will trigger under this condition. There is like some calculation with metrics or whatever is what you want to do, right? There is going to be a test for the alert saying like, can we know that this alert, if the conditions are given, is actually triggering in the sense of like, because we all have written a regular expression that has a star at some point, and you break your stuff. With metrics for alerting is the same. So give me a test for that. And there is the runbook at that point. So we have like a server with like a markdown text. That's it. It's not fancy. It doesn't need to be fancy. It needs to be like something that is useful, right? Yeah. And it's great because it's a simple server that is, if there is a widespread outage at Google, that thing we know is going to be available. Right? And it's this text of like write some help. That's it. There's nothing really fancy in these.
Okay, and if there are any questions from the audience?
Boy, I'm just getting blind.
No hands raised? No? No, I think so.
Well,
no?
Then
okay, well then I guess another. So just